Alright, so this is lesson 1, part 2. We said we weren't going to cover these three. They're covered pretty well in Gen Chem. I'll cover those on request. If someone asks for a video on one of those, I'll give it, time permitting. I just covered this one in part 1. That's the big one. And so what I'd like to do is here for this second part of the video to just cover these two. So we need to talk about formal charge, and then we need to talk about molecular orbital theory and VSEPR. And we spent weeks in principles on that, I think. So we have a pretty small universe that we're going to cover inorganic for that. Okay. So first of all, objective number 5, formal charge. Formal charge is defined different places, different ways. It's in general, they're all equivalent, of course. In general, formal charge is equal to the valence number minus all the unshared electrons minus half of the shared electrons. Okay? So, and of course, the formal charge is always with respect to a particular atom. That's the formal charge of X. Alright, is the valence number of X, the unshared electrons on X, and so on. Okay? So let's look at an example. Water. Okay? The question might be, what's the formal charge on the oxygen? What's the formal charge on the hydrogens? Since they're both the same, I'm not going to say them different. Okay? So what's the valence number of oxygen? Oxygen comes from group 6, so it's 6 minus, how many unshared electrons does it have? It's got 4 minus half of the shared. How many shared does it have? 4, right? So we can see that the formal charge is 0. What about the hydrogen? It comes from group 1. It's got 0 unshared electrons, and it's got 2 shared electrons. So that also goes to 0. All right, let's do one more example, and then we'll move on. Let's take N2O. All right. I went straight to the Lewis structure here. It turns out the structure for N2O is this. I won't try to convince you of that right now, but that's the structure for N2O. All right, so let's look at this. What's the formal charge on nitrogen 1? I'll call this nitrogen 1, nitrogen 2, and oxygen. It is the valence number, which is from group 5, minus all the shared, which is 4, minus half of the, minus all the unshared, right, minus half the shared, which is 4. Okay, so this is equal to minus 1. The formal charge of N2 is 5 minus 0, because it has no unshared electrons, right, minus half, and it's got 8 shared electrons, 4, which gives plus 1. And the formal charge in the oxygen is 6 minus all the shared, all the unshared minus half the shared, which is equal to 0. Okay, this is a big deal, except it turns out that as the semester unfolds, we're going to find that all carbons that have 4 bonds have a formal charge of 0. Oxygen, if it's got 2 bonds and 2 lone pairs of electrons, it's 0. Nitrogen, if it's got 3 bonds and 1 lone pair of electrons, it's 0. Hydrogen, if it's got 1 bond and no lone pairs, it's 0. Chlorine, or any other halogen, if it's got 3 lone pairs and one bond, it's 0. Okay? So, you know, we'll see a trend. If oxygen, for example, then has got 3 bonds and 1 lone pair, it turns out to be plus 1, and so on. Don't memorize that. It's going to be something we're going to accidentally memorize. For now, you should be able to calculate the formal charge. And that's lesson 1, objective 5. Okay? Lesson 1, objective 6 is molecular orbital theory and Vesper and gosh, so on. Okay? You may recall that we talked about the hybridization. So to look at a molecular orbital diagram of a carbon atom, we might find that it looks like that. 1s, 2s, and 2p, right? And if we looked at the molecular orbital diagram of a carbon atom, we would find that it has 2 electrons in its core, 2 here, okay, and then 1 empty. All right, do you recognize that? Well, we found out in Principles of Chemistry, probably Principles of Chemistry 2, we found out that these 4 orbitals, we've got an s and 3 p's. You see that? There's 1 s here and 1, 2, 3 p's. These actually hybridize. Under normal conditions, they hybridize to make 4 identical orbitals. Okay? Where these 4 electrons then can go in each their own separate orbitals. Alright, so this consequently is sp3 hybridized. Alright, with a double bond, that's if it's just got 4 single bonds, okay? And I haven't even shown the molecule that this goes in. I'm just talking about the atom itself. But if you ever have a double bond on a carbon atom, then we find that, I'm not even talking about these 1s electrons down here, right? 2s, 2p's. We find, for reasons which are outside the scope of this conversation, but certainly we're going to use them, is that one of the p orbitals remains unhybridized, and 2 of them become hybridized along with. Right? Can you see this is a 2p orbital, and here are 3 sp2 orbitals. And these are sp2 because they're comprised of 2 p's. Right? Say these 2 p's maybe come down here, and this one is here. Alright, so this is sp2. We're going to go a lot simpler than this in most of our conversations, and we're going to say that an sp is going to has 4 single bonds, or sp3. sp2 is going to have a double bond and 2 single bonds, and sp3 is going to have 2 double bonds. Right? So notice this only has 2 electron groups around it. That's an electron group, and this is an electron group. Okay, these are sp. This has 3 electron groups around it. These are sp2, right? And if you're adding up the superscripts here, that'd be a 1, and that's a 2, right? You can see it's got 3 electron groups, sp2. This has 4 electron groups, sp3. Okay, that's, I think, the most important thing to take from this. All right? And now on to objective, oh, well, still this is objective 6, right? Now that was talking about molecular orbital theory, all in 5 minutes, or 7 minutes, I guess. And to talk about VSEPR, then, we would say that if any atom has got 4 electron groups around it, it's going to be tetrahedral. If it's got 3 electron groups around it, it's going to be trigonal planar. And if it's got 2 electron groups around it, it's going to be linear. Now, I just used the term electron groups. Let me give you a couple examples of an electron group. It's a lone pair. It's a bond. A double bond is also an electron group. A triple bond is also an electron group. Okay? Those are 4 examples of electron groups. Lone pairs, single bonds, double bonds, and triple bonds are all electron groups. So, carbon dioxide, for example, how many electron groups are around that central atom? How many electron groups are on the central atom? 2. Okay? And so that makes it linear. What about ozone? Okay, it's got a plus formal charge on it, a minus formal charge on it. And how many electron groups around that central atom? How many electron groups? Here's the electron groups right here. Right? 3. 1, 2, 4. I mean it's 1, 2, 3, right? 3 electron groups, and so it is trigonal planar. Okay? And then finally, I think methane is a good example to use for that. All right, well, let me not give an example for that. Let me leave you with a question here. N2O. What's the shape? What's the shape of N2O? Okay, be ready to answer that question when we get together in class.